Let's consider this infinite sum today. It stands to reason that this sum should converge. But can we do better than that? Hello, welcome back to the Quant Plus YouTube channel. Today we're going to be discussing this infinite sum. The first step I'm going to be taking is applying the idea of partial fraction decomposition. So if we do that, we'll write a over n plus b over n plus 1 is a times n plus 1 plus bn over n times n plus 1. Then this becomes an plus a plus bn over n times n plus 1. Setting this new expression, an plus a plus bn over n times n plus 1 equal to the inside of our sum, we get to the following. Inside of our sum, we don't see any terms with n in the numerator, so that means that a plus b has to equal to 0, because a and b are the the coefficients of n in this expression. And it also stands to reason that a equals 1. So, combining those results, we'll write 1 plus b equals 0, and accordingly, b equals negative 1. This allows us to write this original sum as two separate sums. And from here, we are going to be using the definition of infinite sums to get to a result. As a reminder, we can think about infinite sums as being a limit of partial sums. With this idea in mind, I'll consider the first partial sum. The first partial sum is given to us by 1 over 1 minus 1 over 1 plus 1, which becomes 1 minus 1 half. Our second partial sum keeps the 1 minus 1 half term from before, but now evaluating this expression up here at n equals 2, we get plus a 1 half minus 1 over 2 plus 1, which is 1 minus 1 half plus 1 half minus 1/3. And the minus 1 half and the plus 1 half will cancel each other out, leaving us with 1 minus 1/3. If we then continue this pattern, looking at the third sum, we again have the 1 minus 1/3 from the first two partial sums. But now we get plus 1/3 and minus 1 over 3 plus 1, with the minus 1/3 and the plus 1/3 canceling each other out. This then becomes 1 minus 1 over 4. And if we continue this pattern, we'll see that the general formula for the nth partial sum is 1 minus 1 over n plus 1. And now, using this idea that the infinite sum is really a limit as n approaches infinity of partial sums, we can find that the infinite sum is given to us by the limit as n approaches infinity of s sub n. In turn, this is the limit as n approaches infinity of 1 minus 1 over n plus 1. This limit evaluates to 1, and therefore we can conclude that this sum evaluates to 1, and that is our final result. So, if you found this content informative, please support the channel by liking this video, subscribing to the channel, and sharing with your friends and family. If you're interested in one-on-one tutoring sessions, please follow the link in the description. Have a great day.